Hi, in this video, we are going to see about the process scheduling in operating systems. So we will be seeing about what is process scheduling and what are all the different kinds of queues we have, and then what is a queuing diagram and all those things we will discuss in this particular video. So first we will see what is process scheduling and then we will move on. So process scheduling, here the process scheduler, it is going to select the available process for program execution on the CPU. So this is the main use or the main aim of the process scheduler. So the process scheduler, it is going to take the available processes and then it will give it to the CPU. Now the CPU will execute that particular process and it is going to give us the outcome. So the main objective of multiprogramming is to have some process running at all the time. So when we do like that, this will maximize your CPU utilization. So maximize the CPU use so that in case we have to quickly switch the process onto the CPU for time sharing system. For example, we will be using Microsoft Word. At the same time we'll be listening to music, and at the same time we'll be downloading some files from the browser and so on. So all these things that can be done at the same time. So everything can run concurrently and all these things can be done simultaneously. So this will maximize your CPU utilization. So the main objective of the process scheduler is to schedule the process to the CPU. So he decides which process to give it to the CPU, and CPU will just execute that particular process and it gives the outcome. So here when it goes like that, so we'll be having some scheduling queues. These scheduling queues are going to maintain the incoming process. So we have three different types of scheduling queues. So the first queue we have is the job queue. So here as the process enters the system, they will be just moved to this particular queue. Once the process enters the system, what we are going to do, we are just going to take that particular process and we are going to put it in the job queue. So the content of the job queue will be stored in the hard disk, that we call it as the secondary memory. So this contains the list of all the processes that are available in that system. So whenever a process enters the system, we will just take it and put it in the job queue. So this job queue is nothing but it is a storage. So we call that storage as the hard disk. So this hard disk is nothing but the secondary memory. Okay, so the next one, the next queue which we have is the ready queue. So here this ready queue will be having set of all the process residing in the main memory, so that are ready and waiting to execute or kept in this particular ready queue. So once the CPU is made available from the ready queue, the process will be taken and it will be given to the CPU. So these are the processes that are residing in main memory, that are very much ready and it is waiting for its chance to get hold of the CPU. So once it gets the CPU, it will run. Okay, so that kind of a process are kept in the ready queue. So the third queue which we have is the device queues. So these device queues, we also call this queue as the IO queue. So this will have the set of process waiting for the IO devices. So we'll be seeing the queuing diagram. In that we'll be seeing the scenario for this. So whenever a particular process is waiting for the IO device, so such a kind of process can be moved to the device queue. So the process migrate among the various queues. So whenever a process comes in, we can't say that it will just come from job queue, enters the ready queue and go out. So it is going to migrate among various queues. Okay, so we will be seeing a queuing diagram and how the process are getting ready and how the process are moving to the various queues. So this is the representation of process scheduling. So this diagram, we call it as queuing diagram. So this represents the queue resources and the flows and everything. So here you see we have a ready queue. So in ready queue, what we saw, which kind of a process we have in ready queue. So we saw the process that are ready and waiting to be executed will be there in your ready queue. Okay, so here right now we have a process that is ready and waiting for the CPU. For example, if I get hold of the CPU, if a process gets the CPU, the process will come in and the process will be executed in your CPU. So the CPU will execute that particular process, and then what it will do, it will just once the process executes properly, if there is no IO request or whatever it is, if it is executed properly, it will be terminated. Or else when a process is coming in, now the CPU is given to the process. So now you see a particular IO request occurs. Okay, when an IO request occurs, what it will do, it will move that particular process to the IO queue. Okay, the process will be moved to the IO queue. So when the process needs the IO device, it will be moved to the IO queue. Now it will be in the IO queue. Once the IO request has been serviced, this particular process will be moved once again back to the ready queue. So this is the second condition. So in the third condition, as we know, we are just using round robin scheduling. So scheduling algorithms are there. So whenever I give my process to the CPU, now it is executing that particular process. According to the round robin scheduling, we'll be having a time slice. So a particular time will be given to each and every process. So that particular time slice expires. When a particular time slice expires, what it has to do, it has to move that particular process to the ready queue. So whenever I'm using the round robin scheduling, the process executes for a specific time period. So after a specific time period, it will just come out of the CPU and it will be moved to the ready queue. So we'll be seeing about the round robin scheduling in the forthcoming lectures. Then we will know how that round robin scheduling is working. So for example, a particular process has been given a time like 3 milliseconds, like 3 milliseconds. That means it will just work for that 3 milliseconds. Okay, 3 milliseconds it will be there. So after 3 milliseconds, it will come out of the CPU and it will move to the ready queue. So this is the third condition. In the fourth condition, whenever I have a process that is ready and when it is given to the CPU, now it is executing the process. CPU is executing the process. For example, that process is going to create a child process. Okay, it's a parent process, it is creating a child process. So when it creates a child process, this process has to wait until the child finish its execution. Okay, so the process is creating a child. With the help of the fork function, the corresponding child should complete its execution. Okay, that's what I told. So whenever a parent process creates a child process, it has to wait for the child to execute first. Once the child completes its execution, then once again the process will be moved to your ready queue. So this is the fourth condition. So the fifth condition is, right now the process is available and it is given to the CPU. Now CPU is executing that particular process. Meanwhile, an interrupt comes in, right? I have an interrupt that is coming in. So the CPU receives an interrupt from the operating system. Now, if it receives the interrupt from the operating system, what it has to do, it has to wait for an interrupt. Okay, it has to wait for an interrupt. That process has to wait for an interrupt, and that interrupt service routine will be done. Okay, once that interrupt service routine is over, once again the process will be moved to your ready queue. So this is the five different situation how the process has been handled. Okay, so how it is executed in CPU and how it is moved to the ready queue. So this is the queuing diagram of your process scheduling, which is very much important. So we have five different maybe we call it as five different states how the CPU handles the process. Okay, so this is your process scheduling. In the next video, we'll be seeing about the producer consumer problem and so on. Thank you.